Okay, hello students. So we are in chapter 3 of our book. I don't know what book everybody else is in, but we're in chapter 3 and it's on solving quadratic equations. And there are five different ways to solve a quadratic. One of the ways to solve a quadratic is by graphing. And when you solve a quadratic equation by graphing, that means you graph the parabola and then you see where it crosses the x-axis, and the actual x-intercepts are the solutions. In this example, where we graph the parabola, notice that the parabola does not intercept or intersect the x-axis. So if you graph a parabola and it does not touch the x-axis and has no x-intercepts, then there would be no real solutions. If the graph crosses and hits the parabola only once, that means we only have one x-intercept, so we would have one solution. And if it hits twice, we have two solutions. So the x-intercepts are the solutions when you graph. Yesterday or the other day, we went over solve by factoring, right? We went over solve by factoring. Today, we want to talk about solve a quadratic equation by using algebra and the square root property. And then later on in the week, we'll talk about solving a quadratic by completing a square and solving a quadratic by the quadratic formula. So today we are here. And we're going to go over solving a quadratic by algebra and square root property. So here we go. So here's an example. So here we have the square root property. So basically the square root property says if you take and you're undoing to try to get x by itself and you're taking the square root, obviously if you take the square root of one side, you have to take the square root of the other side. If you do that, you must have a plus and minus. You might say, well, why is that? Well, let's look at an example. What could I possibly put in place of x that when I square it, that will give me 9? And you might say 3. If I put 3 where x was and I square it, doesn't that give me 9? So x equals 3 is a solution. But is that the only solution? Well, no. Someone else may say, well, what if you took -3 and you squared it? Doesn't that also give you 9? So doesn't x equal 3 and -3? And couldn't we write that as +3 and -3? So aren't there two answers for that? There is 3 and -3, right? So there's a -3 and there's a +3, and we can write that short as plus and minus 3. So that was doing logically, right? We were just thinking, what could you possibly square that would give you 9? We're like, well, +3 and -3. So there are two answers. But what if we weren't thinking logically and we were just using algebra to get x? Wouldn't we want to undo squaring by taking the square root? And if you take the square root of one side, don't you take the square root of the other side? So squaring and square rooting are inverse operations and they undo each other. And then the square root of 9 obviously is 3. So you would say, oh, their answer is just 3. But we know because we undid a variable being squared and it was a variable, that means we have to have that plus and minus. Now, if I just asked you to take the square root of 16, we wouldn't put plus and minus 4. We would just say 4 because we're just asking for what we consider the principal root. Like we just want to know, because I know we were saying earlier, it gets kind of confusing, what times what equals 16. And you might well say, well, -4 times -4 is +16, and so is +4 times +4 is 16. So how come this wouldn't be plus and minus? Because when we're asking for the square root of 16, we're just talking about the positive root, and that's called the principal root. So when we're asking for that, we're just talking about square root of 4. Square root of 16 is 4. Oh my God. So then why are you putting the plus and minus when there's a variable? So when you have a variable and you're undoing a variable and you're taking the square root of both sides, the square root property says you must remember that plus and minus. That's what the square root property says, right? Okay, so now let's go ahead and start some problems and let's see how we go. So here we have a quadratic equation. Notice it's in standard form. And we want to solve it using algebra and the square root property. So we want to isolate the quadratic term. So the quadratic term, this is the quadratic term. So we want to isolate. Remember when we were isolating absolute values? So now we want to isolate the quadratic term. So we want to undo subtracting 3 by adding 3. And that leaves you 2x squared equals 3. Then you got to undo multiplying by 2. So I guess I should have maybe highlighted, right? I guess I should have undone that and highlighted only this part. So we want to isolate the quadratic term. So we want to undo everything that's outside of that squared function. So we have to undo subtracting 3 by adding, and we have to undo multiplying 2 by dividing by 2. And then doesn't that give me x squared equals 3 halves? So that's the first step. So that's the critical first step, is to get this to be just the x squared all by itself. So just like we did with absolute values, we undid everything that was outside of the function, right? All the vertical stretches and all the vertical translations up and down, we want to undo all of those. And now we have to undo the squaring by taking the square root, right? So squaring and square rooting undo each other, and therefore we have to have that plus and minus in there because the square root property says if you're undoing a variable squared. And then you might say you're done, but remember yesterday we just talked about simplifying radicals. So isn't the square root of 3 halves, doesn't that mean the square root of 3 over the square root of 2? And by the way, no decimals, no decimals. You can't have a radical in the denominator, so we're going to do the rationalizing. So we're going to multiply top and bottom by square root of 2. Remember, it's just a fancy way of writing 1. When you multiply the numerators, that gives you square root of 6, and you multiply the denominator, square root of 2 times square root of 2 is square root of 4, and isn't square root of 2 just square root of 4, just 2. And then, are we done? So how do we know if we're done? Are there any pairs hiding in there, or square roots hiding in there, like 1, 4, 9, 16? There's not a radical in the denominator. And can it be reduced? Now you cannot reduce this because one of these, this is under the radical and this is outside the radical. So you cannot reduce something that's under with something that's outside. So we are technically done. So you want to make sure that you have no more pairs, that the radical's simplified, there's no radical in the denominator, and that it cannot be reduced. So our final answer is plus and minus the square root of 6 over 2. So that would be our final answer. You got to make sure you have that plus and minus. We tend to leave out that plus and minus. Okay, problem number 2. We want to isolate the square root. So remember, this is the square root function, and we want to isolate that. So when you isolate that, that gives you, got to mark over here and try to erase it, right? We have to undo subtracting 49 by adding, right? So we got to undo this. So we got to add 49 to both sides. And that gives you the quantity 4x minus 3 squared equals 49. And now that we don't have anything outside the function, right, then we can undo squaring by taking the square root of both sides. And remember, when you take the square root, that squaring and square rooting undo each other. So that leaves me just the 4x minus 3. And we have to put plus and minus. So the square root of 49 is 7, but because we took the square root and we were undoing a variable that was being squared, we have to have that plus and minus. That's what the square root property says. Then we're going to add 3 to both sides. And that's going to give me 4x equals, we're going to write 3 plus and minus 7. So we're just going to leave it like that for now. Right, we're going to put the 3 in front and the plus and minus 7 in the back, and then we're going to divide everything by 4. And that's going to give us x equals 3 plus or minus 7 divided by 4. Now we're not done, because what that means is that means two things. So let me erase some of this so we can have some more room. So that means we have this means two things. It means 3 plus 7 divided by 4, and it also means 3 minus 7 divided by 4. So this gives you 10/4, which reduces to 5/2. And this gives you -4, but divided by 4 is -1. So the answers are 5/2 and -1. And remember, those are also the x-intercepts if you were to graph it. So not only are those the solution, those are also the x-intercepts. Okay, let's look at the next few. Okay, so don't forget, you can pause the video, you can stop it, you can rewind it. So solving by algebra and using the square root property is we want to isolate the quadratic term. So this is the quadratic term and we want to isolate it, just like we did with absolute values. So that means I need to undo the subtracting 4, and I'm going to have to undo the multiplying by 3. So remember, we have to add 4 first, and that gives me 3 times the quantity x plus 1 squared equals 10. Then we're going to divide out the 3, so that gives me x plus 1 quantity squared, is how you read that, equals 10/3, no decimals. Leave it without decimals. You got to work with the fractions. Then we can undo the square root, the squaring. So we're going to undo the squaring by taking the square root. Those are inverse operations. So squaring and square rooting undo each other. And because I took the square root of a variable that was being squared, I have to have that plus and minus. And then I have to simplify the square root of 10/3. So remember, that means the square root of 10 over the square root of 3. I cannot have a radical in the denominator, so I have to multiply by square root of 3 over square root of 3, which is really just a fancy way of writing 1. And then if you multiply straight across, doesn't that give you the square root of 30? And isn't the square root of 3 times square root of 3, right? So when you multiply the denominators, doesn't that give you the square root of 9? And isn't the square root of 9 just the number 3? So we got to make sure, is the square root of 30 have any pairs hiding in it or perfect squares? Isn't 30 just 3 times 10, which is 3 times 2 times 5? So notice there are no perfect squares and no pairs. So the square root of 30 is simplified. There's no radical in the denominator. And 3 and 30 cannot be reduced because 30 is under the radical and 3 is not under the radical. So those cannot be reduced. So that's going to give you the square root of 30 over 3. That was just to simplify the radical. Now we have to subtract 1 from both sides. And that's going to give us x equals -1 plus and minus the square root of 30 over 3. Now, let's simplify that. So when you have a fraction, so let's take a look at that. When you have a fraction like -1 plus and minus the square root of 30 over 3, and you want to add, don't you have to make this have the same denominator? So can't 1 be written as -3 over 3? Isn't that another way of writing -1? And then doesn't that give you, keep the denominators the same? And then doesn't that give you -3 plus or minus the square root of 30? That should have been a 30. So that's going to be our answer for the second one. So the second one is going to be, and we can write it 2 different ways. We can write -3 plus the square root of 30 over 3, comma, -3 minus the square root of 30 over 3. Or we can just leave it like this, because isn't this mean the same thing? So don't these mean, aka, also known as, don't those mean the same thing? Right? So here we have what we call 2 real irrational roots, or solutions, or x-intercepts, right? We'll talk more about this vocabulary a little bit later, right? So we'll talk a little bit more about that vocabulary, but that's the answer for that problem. That was a doozy. Okay, number 4. We need to add 36 to both sides. And that gives me the quantity 5x minus 7 equals 36. Oh, forgot my squared. Then we need to, now that we have it isolated, Then we can take the square root of both sides because we need to undo the squaring. And squaring and square rooting undo each other. So this gives me 5x minus 7. And don't forget, because we undid a variable that was being squared and we undid it using the square root, we have to have plus and minus. And then isn't the square root of 36 just 6? Then we're going to add 7 to both sides. So that gives me 5x equals 7 plus and minus 6. Then we're going to divide out the 5. And that gives me x equals 7 plus minus 6 over 5. And that's not your final answer, because remember what that means. So if you can simplify, you have to simplify more. So that means 7 plus 6 divided by 5. And it also means 7 minus 6 divided by 5. So that would equal 13/5 and 1/5. So the two answers are 13/5 and 1/5. Does it matter which order you write your solutions? No. So these are two real rational solutions. We also refer to them as x-intercepts. We also refer to them as roots, right? So those are two real rational roots. This part you don't really understand too much about. Maybe you don't understand the word real rational. We'll go over that vocabulary another day, but I just want to kind of throw it out there for you. So you do have to finish this. You do have to do 7 plus 6 divided by 5, and then 7 minus 6 divided by 5 to get your final answers. So you can't just stop. Some people will stop right here, and they'll say, I'm done, and then we say, nope, sorry, you didn't finish. You did not finish, so you got to make sure that you finish the problem. Okay. Okay, last one. I probably could go over some more, but this is just supposed to be a little review, or come in and get some extra help to go over a few more problems if this isn't a good enough for you. So, excuse me. Okay, so if we're solving by algebra, we want to get all the quadratic terms on the same side. So I'm going to subtract 3x squared from both sides. And that gives me 1x squared, or x squared minus 5 equals 7. Then remember, we want to isolate the quadratic term. We want the quadratic term to be by itself, so I want to undo subtracting 5 by adding 5 to both sides. And then now I can use the square root property that says I've got to take the square root to undo the squaring. So I got to take the square root of both sides. And because I undid a variable that was being squared by taking the square root, I have to have that plus and minus in there. So that's going to give me x equals plus and minus square root of 12. Can I leave that as my final answer? No, because if there is a perfect square or pair hiding in 12, I must simplify. So can't 12 be written as 4 times 3, which is the square root of 4, times the square root of 3, and isn't the square root of 4 just 2? So your final answer must always be in simplified radical form, no decimals. So my answer is a -2 square root 3 and a +2 square root 3. You can write it out and separate it, or you can leave it as it's in its plus and minus form. Notice that we have two real, but because of the square root, those are irrational solutions, or x-intercept, or roots, or zeros, right? Because aren't x-intercepts sometimes also called the zeros, right? So those are all the different names that we can call that. Again, you probably don't know what two irrational means, and we'll go over real rational and real irrational another day. But when you have the square root, those are called irrational solutions. Okay, that's it for today. Solving quadratics by using algebra and the square root property.